Okay, so we have prime numbers, compositive numbers. What else we have? GCF, LCM, and prime factorization as well today. Okay, so let's review them really quick. Prime and composite numbers. What makes a number prime and what makes a number composite? Okay, so let's take a look at a few numbers here. Let's just create a few. Here we go. And let's take the numbers 10, I don't know, 15, 23, and 38. Okay, so 10 is a prime or composite. Well, let's look at 10 and see if we can list all the numbers that you can think of that multiply, all the factors of 10. So you get 1 times 10, and you get 2 times 5. So 10 is going to be a composite number. Why is 10 a composite? Because its factors, there's more than 2 factors. It has 1, 2, 3, 4. Okay, so a composite number is a number that has more than 2 factors. Okay, let's try 15. You get 1 and 15, 1 times 15, those are 2 factors. You got 3 and 5, because 3 times 5 is 15. Is there any more? No. So how many factors do we have? 4, which makes 15 a composite. 23. Numbers that multiply give you 23. Well, there's always 1 and 23. And there's nothing else. So there are only 2 factors, the number 1 and the number itself. So 23 is a prime number. Okay, so a prime number is a number that has 2 factors, the number 1 and the number itself. Try 38. 38, we got 1 times 38. And we also have 2 times 19. And this has 4 factors. So 38 is a composite. Okay. One special case, 1. 1 is not a composite or a prime number. It's neither. Okay, so 1 is not prime nor composite. Because 1, if you look at number 1, what numbers do you know that multiply give you 1? It's just 1. 1 times 1, which is the number 1. Okay, and it only has 1 factor. Okay, because you're not going to count these twice. Okay, so 1 is a special case where it's neither prime or composite. Prime factorization. Okay, prime factorization, we want to write 56 as a product of prime numbers. Okay, so the first thing, hopefully you remember this. Let's break these up. 56, you can use 7 and 8. We're going to circle the 7 because 7 is a prime number. The 8, you can use 2 and 4. 2 you circle because it's a prime number. And 4 can be broken up in 2 and 2 again. So every time you hit a prime number, you circle it so you know you don't have to continue. And 56, another way of saying 56 is 2 times 2 times 2 times 7. It's the same thing. Okay, or using exponents, you will write 2 to the 3rd power times 7. Okay, so the prime factorization of 56 is 2 times 2 times 2 times 7, or 2 to the 3rd times 7. Try 84. Think of any 2 factors that multiply 84. It doesn't matter, you will always get the same answer. So I'll choose 7 and 12. 7 is a prime, I circle. 12 I continue. 12 is 2 and 6. 2 I circle because it's prime. 6 I continue to 2 and 3. 2 is a prime, I circle. 3 is a prime, I circle. So I am done. So another way of saying 84, you can say 84 is the same thing as 2 times 2 times 3 times 7, or 2 to the 2nd power, because it's 2 multiplied by itself twice, times 3 times 7. Okay, always write it in order, okay, from least to greatest. Okay, makes it nice and pretty. That's prime factorization. Okay, it's rewriting a number as a product of its prime. GCF, okay, a lot of ways of doing this. Okay, so I guess I'll do it all ways. 36 and 20. Greatest common factor. You're looking for the greatest number that goes into 36 and into 20. One way of doing this is to list your factors. So you can list starting with the easiest one, which is 1 and 36. Okay. put them a little bit far away from each other because you have to write all the factors inside. So you can go 2 and 18. 3 also goes. 3 and 12. 4 and 9. And then we have 6. Okay, you don't need to write 6 times 6 twice. 20. 1 and 20. 2 and 10. 3 no. 4 yes. 4 and 5. And I think that's it. So you want to see which one. They have the 1s in common. They have the 2s in common. They have the 4s in common. And that's about it. So the GCF of 36 and 20 is 4. Okay, that's one way of doing it, which is listing all the factors. You got to be really comfortable with your times table, which you should be by now. Okay, another one is the slide method. And hopefully you still remember. You can write 36 and 20. All right, so think of a number that goes in 36 and 20. You can use any number. Okay, let's use 2. 2 goes in 36 18 times, and here 10. Okay, can we still go on with the slide? Yes, we can. Another number that goes into 18 and 10 is 2. Okay, and which gives us 9 and 5. Okay, is there another number that goes into 9 and 5 besides 1? Okay, so if it's not, your slides ends right there because you can't continue with 9 and 5. There is no number that goes into 9 and 5. So your GCF are these two numbers right here. Okay, the side numbers, the product of those side numbers. So 2 times 2, which is 4. Okay, that's your GCF. Okay, so 2 methods for you to do that. Okay, let's look at our word problem. Here we go. Tina bought 48 pencils and 56 markers. She wants to put them in separate boxes. What is the greatest number of boxes that she needs so that each box has the same number of pencils and the same number of markers? Okay. So this is a GCF problem, and how do I know that? Because I shall underline. I can do this. Here's my keyword, the greatest number. So there's definitely a GCF problem. Okay, so let's just write this down. 48 pencils. She has 48 pencils, 56 markers. P for pencils, M for markers. So you need to create boxes or pencil cases, and she wants to put these in here. Okay, so she wants to know how many pencils can she put in each of those boxes. We don't know how many boxes yet, so it could be a lot of boxes. Okay, so we don't know how many boxes yet, so that's just to illustrate what we're doing. So find the GCF, and I will do the slide method because they're big numbers. Okay, I would use slide method for big numbers, and I would use listing all the factors with a small number. So 48 and 56, think of a number that goes into both. Let's see, 2 goes into both. Is there probably there's a higher? Yes, there is. Let's just use 2. So if it's 2, it's 24, and here it'd be 28. Is there another number that goes into 24 and 28? Yes, there is, and we can use 2 again. 2 goes into 24 12 times, and 2 goes into 28 14 times. Is there another number that goes to 12 and 14? Yes, there is, which would be 2. It'd be 6 and 7. And there are no other numbers that goes into 6 and 7, so we're done. Okay, so our slide stops right there. And to find our GCF, we're going to take the numbers that are on the side here and multiply them. 2 times 2 times 2. So GCF is 8. What does that mean? It means that I need 8 boxes. So let me erase this at the beginning. Okay, so let's see how this works. Because you're not done. Well, it depends. This question didn't say how many pencils will go in each box and how many markers will in each box. It just asked you for the number of pencils. So boxes, I'm sorry. So you know we're going to have 1, 2, 3, 4, 5, 6, 7, 8. So that's the greatest. You can't buy any more because otherwise these two numbers are not going to work. What does that mean? So if I have 8 boxes and 48 pencils, it means that each box will carry 6 pencils. 48 divided by 8 is 6. So each box will get 6 pencils. And notice that each box has the same amount of pencils. 6 pencils, 6 pencils, 6 pencils, 6 pencils. Now, markers. If I have 56 markers and 8 boxes, each box will have 56 divided by 8 is 7. 7 markers, 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 7 markers. And that is our problem. Okay, so number of boxes that she can buy, or she should get, 8 boxes. And if she has 8 boxes, every box will carry 6 pencils, and every box will carry 7 markers. Okay? And then we have LCM. LCM, least common multiple. Okay, so let's say which way we can do this. We can still use a slide. All right, let's try doing multiples. You know what? Let me change this. I'll still do it, but let me pick another one. LCM of, I don't know, 4 and 9. All right, just for that, so that you can see. So the LCM of 4 and 9, let's go back for a second, would be listing all the multiples first. 4, 8, 12, 16, 20, 24, 28, 32, 36, 9, 18, 27, 36. So the first number that they share in common, and this could go on a little bit further, and they'll share other numbers, but the first number that they both share is 36. 36 is the first number that 4 and 9 can go into. So the least common multiple of 4 and 9 is 36. Okay, so 15 and 24, it's a little bit harder because probably get a bigger answer. So let's see, 15, multiples of 15, 15 times 1 is 15, 30, 60, 90, what am I doing? 15, 30, that's correct. Then we have 45, 60, 75, 90, 105, 120. Hopefully one of them will hit. So let's see, 24, 48 plus 24 is 72. 72 plus 24 is 96. Plus 24 is 120. Oh, yay. Okay, we didn't have to go that far. So 120 is the LCM between 15 and 24. It's the first number that 15 and 24 can go into. Okay, and that's LCM. Slide method. Let's do the slide method for 15 and 24, which is probably would have been the easier way. So 15 and 24. So number that goes into 15 and 24 in this case would be 3. So 3 goes into 15 5 times. 3 goes into 24 8 times. And LCM, okay, it's a little different. You're going to take all the numbers here. The numbers on the sides and the number on the bottoms here. And you're going to multiply them. So 3 times 5 is 15, and 15 times 8 is 120. You get the same exact answer. So you're I think the slide method is a little bit easier than listing all the multiples. But pay attention to the questions. Sometimes they will ask you to list or do one way instead of the other. Okay? All right, so let's look at a question. All right, so how do I know this is an LCM question? Let's see. Well, radio station A plays a rock song every 8 minutes. Radio station B plays a country song every 9 minutes. If it is 3 p.m. right now, at what time will they be playing a rock song and a country song at the same time? How do I know this is an LCM question? It's because I want to know when two things that are happening over and over again will meet down the road. So there's a rock song that plays every 8 minutes, and the other one every 9 minutes. Country song plays. So at some point they should meet. So LCM of 8 and 9. Okay.
Gonna sleep like tomorrow?
Yep.
Get into it?
Alright, so where were we? So we want to know when, at what time both stations would play one a country song and one a rock song at the same time. Because at 3 o'clock is when we start. So let's figure out. So this is an LCM question. Okay. And we actually should have room here. And we want to find the LCM of 8 and 9. small numbers. You can list them. So you get 8, 16, blah, blah, blah. Goes all the way to 72. And 9, 18, 27, blah, 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 all the way to 72. That's one way. So you know that LCM is going to be 72. If you did it with a slide method, 8 and 9, is there a number that goes into 8 and 9? No, there isn't. So you end up multiplying these two, which gives you 72. So either way, the LCM is 72. Now, what does that mean? It means that 72 minutes after 3 o'clock, they will play at the same time. Okay, so if it's 3 o'clock now, and your 72 minutes is the same thing as saying an hour and 12 minutes. So at 4:12, radio station 8, at 4:12, radio station 8 will press play, and they will play a rock song, and radio station B will press play again and play a country song. So they both be playing a country and a rock song at the same time. Okay? And I think that's that. Okay, so that's your little review.